Hello and welcome to Education at SSBJ online video tutorials. We were in chapter Motion of class 9th. In this video tutorial, we'll pick up few textbook examples and here we go. Joseph jogs from one end A to another end B of a straight 300-meter road in 2 minutes and 30 seconds and then turns around and jogs 30 meters back to point C in another minute. What are Joseph's average speed and velocities from A to B and then from A to C? As I said already that we need to visualize the problem so that we'll understand what are the information which are given and what are asked. So let us start. Joseph jogs from one end A to another end B. And what is the distance? That is 300 meter, right? So 300 meter is the distance and he takes 2 minutes and 30 seconds, right? 2 minutes and 30 seconds to go from A to B, right? Now look at this unit now. We all know about International Standard Unit, which we call it as SI unit. But minute is not a SI unit. SI unit of distance is meter. Now we have to convert this into seconds. So you all know it's a very simple one. 2 minutes 30 seconds is equal to 120 seconds plus 30 seconds, which is equal to 150 seconds. So that means Joseph from A to B, which is of distance 300 meters, takes 150 seconds. Right, this is one part of the problem. Then he turns around and jogs 100 meters back to point C. Then he turns around and jogs 100 meters back, right? So this distance is 100 meters and he takes time 1 minute, which is equal to 60 seconds, right? And what is this point called? It's C, right? So once again, he goes from A to B and then comes to C, right? What are Joseph's average speed and velocities from A to B and from A to C? We all know that average velocity or average speed, right, can be calculated as, let me write here, average speed equal to total distance covered divided by total time taken. So this is very important one. Whereas average velocity is displacement occurred divided by time taken. Now to remind you, distance is the actual path covered by the body. Actual path. Actual path, you have to go on this path and measure, that is the distance. Whereas displacement is the shortest route between A to B. So this one is displacement. Both are different. But in case of body moving in a straight line, let's say from A to B, then the shortest path as well as the actual path both are same. So in this case, displacement, right, is equal to distance, right? With this information, now we shall start finding average speeds and velocities first from A to B and then from A to C. So here we go, average speed from A to B, right? So average speed is equal to, as I said, total distance divided by total time. Let me continue here. The total distance is from here to complete from B. That is how much? 300 meter. So this one divided by total time. How much time? You should not take 2 minutes here. In this minute unit you should not take. You have to take 150, right? Which is equal to 2. 2 what? This is in meters and this is in second. So this will be meter per second, which is the SI unit of speed, right? And again, average velocity, which is equal to displacement divided by time. And what is the displacement here? Displacement and distance are same because from A to B, there is no change in direction. Therefore, a displacement is also equal to 300 divided by time 150, which is equal to 2 meter per second, and therefore here from A to B the speed as well as velocity remains same. This is the first part of our problem. Now we shall go for the second part of this problem, and what is that? Same average speed and average velocity we should need to find from A to C. And which is that A point? From here to C, right? To come to C, he has to reach first B and then from B to C, right? So let us write average speed from A to C. And what is the formula for average speed? Total distance, because we have already done this, total distance divided by total time, right? Which is equal to, what is the total distance here? Total distance is 300, that is from A to B, plus again 100, that is from B to C, because we are calculating average speed from A to C. So we have to add the distance 300 and then 100. Totally it becomes 400 divided by how much of time he takes? 150 plus another 60. So it is 210, right? 210, and that is equal to 400 by 210. If you calculate, it will become 1.9 meter per second. Now we'll go ahead and find out average velocity, because we need to find average velocity also from A to C, that is from A to C. Now here you should remember average velocity will be equal to not distance by time, it should be displacement by time. Please remember this, displacement divided by time. And what is the displacement from A to C? Now you should find out the displacement from A to C, that is from A to C. Total distance from A to B is 300 meters, and then from B to C is 100 meter, right? And you know that displacement is nothing but the shortest distance between A to C. And what is the shortest distance between A to C? 300 minus 100, that is 200 meter. If you want to go from A to C by a shortest distance, it will be 200 meters. But what about time? Time remains same. To reach from A to then B and then to C, it has taken 150 plus 60, which is equal to 210 seconds. So therefore here displacement is 200 meters divided by 210 seconds, which is almost equal to 0.9. I'll stop here for single digit, meter per second. We will go for a next question. It's about a motor boat. A motor boat starts from rest. Now what does it mean? Start from rest. Initial velocity is 0. As I said, initial velocity is represented by a small u. Please refer all those videos which are in this series, all 4 to 5 videos where we have taken up few questions on equations of uniformly accelerated motion. Okay, starts from rest means initial velocity is 0, then it accelerates at the rate of 3.0 meter per second square. If you look at this unit, you will come to know that it's a acceleration. Otherwise, accelerate, it is already told, is 3 meter per second square. How far does the boat travel during this time? How far? And that is distance, that is yes, either distance or displacement. So this is given, and what else is given? 8 seconds. So somewhere here I will write t is equal to 8 seconds. And what to find? To find yes. Now we have three equations, you all know. V is equal to u plus at, s equals ut plus half at square. These are the equations of uniformly accelerated motion. V square minus u square equals 2as. Now out of this you have to choose as per the problems and informations given in this. We need to calculate, since yes, that means we have to either go for the second as well as the third equation. But in the third equation we are not given with final velocity. So that's why we cannot take. So we'll go for the second equation. So formula which is to be used, S equals ut plus half at square. Therefore our calculation is S equals u is 0. Since u is 0, the entire ut becomes 0, plus 0 plus 1 upon 2. A is, you see, 3 into 3, and t square. T is 8. So 8 whole square, right? That is equal to, S is equal to half into 3 into 64, right? 2 ones are 2, 32s are, that is equal to 96 what meter. So therefore the boat after 8 seconds covers a distance of 96 meter if it goes with the acceleration of 3 meter per second square. You can write the answer afterwards here, right? We'll go for next question. A driver of car traveling at 52 km per hour applies a brake and accelerates uniformly in opposite direction, which means it's a negative acceleration, right? A is negative, which means velocity is reduced. When brake is applied, velocity definitely will reduce and finally it comes to 0. The car stops after 5 seconds, right? So initially it was 52 km per hour, brake is applied, and then velocity changes, it reduces, and then after 5 seconds a first car comes to halt. Another driver going at 34 km per hour in another car applies his brakes slowly and then it stops in 10 seconds, right? On the same graph paper, plot the speed versus time graph. Either you can consider this as a speed or velocity, because we are dealing with the situation where the body is moving in a straight line, right? So you can even write speed as velocity. So let us split this entire question into different parts, right? So first one is a driver of car traveling at 52 km per hour applies a brake and then it stops after 5 seconds. Second driver is 34 km per hour. He has the speed and then he stops after 10 seconds. We have to plot it on one graph. We'll take this entire matter onto one side, right, and then take the graph paper. But before that, we shall write what is initial velocity in this. Car is already traveling at 52 km per hour, therefore its initial velocity. And what is the symbol used for initial velocity? Small u, and u is 52 km per hour. Now it is in kilometer per hour. If you calculate this 52 km per hour, that is the initial velocity, in terms of meter per second, which is the SI unit, what we have to do? We have to multiply it by 5 by 18, which is a shortcut of for converting it into meter per second. You get a meter per second here. Okay. Otherwise, you have to convert that kilometer into meter, multiplying by 1000, and then r into second, 60 into 60. You have to divide, and then you get this particular number. So straightway we are multiplying 5 by 18. So when you multiply by 5 by 18 to this number, you get answer 14.4 meter per second, right? We have converted this. But what is a final velocity? A car stops after the brakes are applied, so final velocity is 0. And in how much of time it stops? T is equal to 5 seconds. So this is the information given in the first part of the problem. In the second part of the problem, a second car, this is the first car and this one is the second car, which is having initial velocity is 34 km per hour. When you convert this again by multiplying by 5 by 18, you can convert into meter per second, you get the answer 9.4 meter per second. The first car is moving in 14.4 meter per second. Second car is moving in 9.4 meter per second, and where both the velocities, final velocities, will be 0, because after the brakes are applied, they slow down and then they stop. But only difference is First car stops in 5 seconds and second car stops in 10 seconds. Well, now we will take the graph and draw a first y-axis and write that as a y-axis and then x-axis, right? And please remember, on y-axis you have to write or plot either speed, or you can consider it as a velocity here, and that too in meter per second. That's why it is converted into meter per second. Okay, and on the time axis, that is on x-axis, you have to write time in second. So since the number of divisions are less here and we have a range up to 14.4 meters on the velocity side on y-axis and till 10 seconds on x-axis, so let me divide a time axis, that is x-axis, into 5 divisions, and each of these divisions, one division is equal to 2 seconds. So that will be 4, 6, 8 and 10, because we require 10 second maximum. On the other side, on velocity axis, that is on y-axis, we'll start with again 2 meter per second. It is in meter per second because it's a velocity. And even on velocity axis, we have each division is equal to 2 meter per second, so that we can reach up to, this is 14.4 meter per second, typing mistake, and we can reach up to 16 here, right? So this is the velocity in meter per second, this is time in second, and now we shall take this information and then these information and draw the graph. But before that, we have to take and consider the units on x-axis. This is on x-axis, one division is equal to 2 seconds. One division is equal to 2 seconds. In the same way, on y-axis, one division is equal to 2 meter per second. So this work is completed. Now we'll take this particular value on the graph. This is the initial velocity. That means a car which is already moving, right? Already moving with a velocity of 14.4 meter per second, and where that 14.4 meter per second, somewhere here, right? So roughly I am making a point there, it's a 14.4 meter. So this is 14.4 meter per second, right? And then the velocity dropped because the brakes are applied, and finally it comes to 0. So velocity becomes 0 after how much of second? 5 seconds. So next point will be somewhere, this is 4 and this is 6. So somewhere here it will be a 5 second. So when you join these two, you get a graph of that car which is running in 52 km per hour. Okay, so this is over. Second one, this particular car is already moving in 9.4 meter per second, 9.4 meter per second. And where is that 9.4? Somewhere here is the 8 and this is the 10. In the center it will be 9. Roughly it will be somewhere here. So 9.4. So you can take it as approximate marking, and 9.4, and here it meets at 10 here. Okay, somewhere it should be somewhere here, right? So our next graph is this way, and this is the graph of a car which is moving in 34 kilometer per hour. So we have completed the graph, right? The next question, if you go behind and see, what is the next question? Which of the two cars travel further after the brakes are applied? So whether this car has traveled further or this car has traveled further, for that we have to find out the distance. And what is the distance here? Distance can be area. Distance is equal to area below velocity versus time graph. Now if you want to find out the distance traveled by the car which is going in 52 km per hour, you have to find the area of this triangle. And what is the area of this triangle? Okay, now we shall calculate distance traveled by first car, which is equal to area of triangle. We'll name it ABC is equal to ABC, which is equal to half into height into base, right? That is equal to half. And what is the height here? So have your attention here. Height is the length of AB. And what is the length of AB? The length of AB is 14.4 meters per second. So we can consider it as 14.4. Right? From here to here it is 14.4. Look at this number. So this is equal to 14.4 into what is the base? Base is 5 second. Okay, base is 5 second. So it's 5. That will give you a number which is equal to 36. And 36 what? Meter, because we are calculating the distance, right? This is how you can calculate the distance covered by the first car. Now what is required here is for you to calculate distance traveled by the car which is running in 34 km per hour, and compare these two distance and find out which traveled far. Okay, so let me expect the answer of this question in the comment box. Thank you.